Hi, I'm Amie Elcan from CenturyLink, and I work in the Data Strategies organization. And prior to CenturyLink, I worked at Quest, US West, in a mathematical modeling group. And our team would support network leadership, strategic planning, capacity planning, product regulatory, and decision support through mathematical modeling. And my focus has been traffic modeling, traffic assessments, layer 3 and above. And what's changed in the past 10 years is I used to do a lot of theoretical traffic modeling. I don't need to do that anymore because collection and storage has improved so much that my role has shifted to analytics and statistical modeling. Okay. So I chose this topic today because the trends in internet usage are having significant consequences on all segments of the network. And I want to show a few consequences. So I'm going to start with some background on internet usage trends. And then I'll dive into the weeds on 95th percentile billing and some other topics. And then I'll come back and show some consequences. Okay, so internet usage has been increasing dramatically, and I've been watching it for about 8 or 9 years since we started collecting really good data. 4 years ago, the average download per month was 3 gigabytes. So a gigabyte is about an hour of Netflix at 2 meg, 5 or 6 hours of YouTube, depends on the video quality. It's about 30 hours of browsing. So 4 years ago, the average was 3 gigabytes. It's now 20. And then usage has like a power law distribution to it, like an 80-20 rule. The top 1% of users are downloading over 170 gigabytes per month. So that's equivalent to like 5+ hours of Netflix standard definition per day. So very significant. So because of this dramatic increase in usage, and it's not just the top 1%, we keep seeing more and more people moving into that bucket. There's been a trend in moving towards consumption-based billing. And obviously all the smartphone providers are doing that already. LTE, and AT&T does it with its cap. It has a cap of 150 gigabytes per month, which is pretty generous. But the usage is increasing so dramatically that something has to be done. And what we saw about 4 or 5 years ago were the top 1% of users were heavy peer-to-peer news group users. And now it's video. It's over-the-top video. That's our killer app. Okay, so what's causing the dramatic increase in usage is video. And not only this is going on, but video is changing the peakedness of the traffic. And by peakedness, I mean that the mean to average has changed dramatically, and that impacts efficiencies and costs on the network. So about 4 years ago, I went back and looked at a lot of my traffic data, and the mean to peak to mean was about 1.4. Today, it's about 2 to 1. So it keeps increasing because more and more people are watching video from 7 to 11 at night. And then another thing I've seen is the number of people on the internet, the concurrent users, are increasing because people are cutting the cord. They're turning off the TV, they're using the internet. It's not that they were using the internet before and they're switching to video. They're not watching television and they're using the internet. Okay, so now I'm going to go into the weeds a little bit, but I'll come back to this peak issue. Okay, what is 95th percentile billing? It's also called burstable billing, variable rate billing. It's an alternative to flat rate billing or consumption-based billing. It's billing where it's a method where you are billed for a threshold of usage, 95th percentile, and any traffic above that, you're not billed. So if there's any bursts of traffic above your 95th percentile threshold, there's no charge. Okay, how is it computed? The way it's computed is traffic's generally measured every 5 minutes. So you have like 8,600 measurements in a month. Sort those, toss out the top 5%, about 400 measurements, and then you're left with a number, and that's your 95th percentile value. The 95th percentile means that for about 36 hours out of a month, your traffic could exceed that level and there's no charge. So that's significant. That's about over 1 hour a day. And where are these measurements taking place? This is typically a billing method for transit customers, CDN content customers at the edge of the network. So the measurements are taking place at edge routers on the edge of the backbone. And this is just to show how it's done. You take 8,600 measurements, sort them, take the top 5%, toss them away. Okay, here's a visual. This is an example data for a month. And along the x-axis are 5-minute intervals. Along the y-axis is bandwidth. I just made it generic. Let's say it's gigs. And actually, this red line is in the wrong place. I meant to correct it, but it should be at 25. 25 is the 95th percentile on this chart. And the maximum's 31, and the average is 15. And the point is anything above the 95th percentile, which is actually 25, is not charged. And you could think of the area, think back to calculus, the area under the curve is the volume, it's the throughput, it's the gigabytes. If you divide it by 8, it is exactly that. So just keep in mind the area under the curve, under these curves, is the volume. And here's a closer look at one day. So look at the intraday pattern. And you can see the spike later in the evening. And this is pretty typical for content traffic, video traffic. The max and 95th percentile aren't that different. One is 26 and the other is 24. They're pretty close together. So the 95th percentile billing makes sense for CenturyLink because we have to design to the peak traffic. But 95th percentile, my question here, is it close to the max? Is it a good representation of the peak? Okay, so this is a question I had. I mostly work and study usage on the access network. But when I started working with the backbone planners, they talked about how they measure, they bill based on the 95th percentile peak in megs per second. So I wanted to be able to convert from what's this megs per second, how much does it really cost per gigabyte in a month? How do you convert? And so here's a way to convert. You can take a 95th percentile measurement, divide by the peak to mean, 95th percentile to mean, the ratio. You get an average. Divide by 8. Now you're working in bytes. Multiply by the time in the month. And then you get how many megabytes, terabytes, gigabytes are transferred through the month. So to put some numbers behind this, because that's a little abstract, is say you have 100 meg, and that's your 95th percentile measurement. So your max may have been above that for up to 36 hours that month. Then divide by 1.8, that's a pretty typical 95th percentile to mean ratio, and you get 56 meg. Okay, then divide by 8, and you're dealing with megabytes per second. Multiply by seconds in the month. Then I get 17 terabytes. Okay, now I want to figure out what's the cost per gigabyte to the customer, to like a transit customer. Say they're paying $3 per meg. Now I got that number from Bill Norton's Dr. Peering website because he showed the trends in the past 10 years for transit prices. So I got that from a public website. So say a customer's paying $3 per meg, divide the terabytes into that, and it's 1.7 cents per gigabyte. That's pretty cheap. What I want to point out here is that's not fixed. It depends on two things. The cost per meg and that peak to mean ratio. So look at this table. I have price per meg. I have a range from 1 to 5. And then I show the peak to mean ratio, 1 up to 2.25. It's typically 1.8 or 2. And you can see the cost per gigabyte ranges from half a penny to 4 cents. So it depends on your peak to mean ratio. And so what this means as the traffic's more peaked intraday, then your throughput efficiency decreases. And you as a customer, your transit customer, you're paying more per gigabyte because the traffic it's less efficient to deal with. And then my chart on the bottom, I'm showing if you have like a fixed 1 meg stream, your throughput can be 316 gigabytes per month. But say your 95th percentile is 1 meg, but then it increases, the peak to mean ratio increases, your efficiency goes down. You can't get as many gigabytes through. So it helps to see a picture. Okay, so this picture, say this is 1 day of traffic, intraday pattern. Suppose your traffic were constant and your 95th percentile and your mean were both 1. Then that area under the curve is essentially your throughput. If I divide it by 8, it's your throughput. Now that same area can be represented by that blue curve, but you're paying 1.8 times as much. The 95th percentile for that blue curve is 1.8. So your efficiency goes down. And you could sort of think of the where there's no bandwidth as sort of unused bandwidth. It's your proportion of inefficiency. So in this case, that area where there's no bandwidth is about 40%. And here I'm just showing that for different peaks, there's about the same area under the curve. So you get the same throughput, but the customer will be paying different amounts. Okay, so the main point is, more peak of the traffic, the more you pay per gigabyte, the less efficient it is. Okay, and I'll skip that. So back to my picture I showed earlier where I had 30 days of traffic. Here I'm showing the 95th percentile, which in this case is 24, the mean's 15. Your goal is to get those two things as close to possible together, and it reduces your peakedness, and then you get more efficiency in your network. So what we're seeing, what I've observed in some of our traffic measurements is some of our customers are trying to mitigate the effects of the peakedness and reduce this peak to mean. So by shifting the traffic to other interfaces, and the traffic will spike, but those spikes occur less than 36 hours per month. So it's a way to like throw some bandwidth over here, but keep your 95th percentile billing down at a low level. So this sort of artificial tampering with the natural traffic has an impact on the CenturyLink backbone. Because as our traffic comes in, when we have these spikes from 1 hour to the next that are 80% more, and they should be maybe 15% more, then the backbone has to deal with that. So this sort of erratic, unpredictable traffic has an impact on our costs, because the more variable the traffic, the more expensive it is to design to. And this chart down at the bottom right, again, you can think of the area under the curve as volume. And where I have that red line that's horizontal, that's 95th percentile. And the peak was about 80% higher than the 95th percentile. And that area was about 5 or 6%, and it should be about 2% if it were natural traffic. And then one other observation, somewhat related, is here I'm trying to reconcile on the consumer side of the network and the content provider side of the network pricing, and who's paying the price to pay for the infrastructure and the backbone. What proportion of pricing is paid by whom? So think of the internet's really a two-sided market, and CenturyLink is a market with two distinct user groups, consumers, content providers. We get revenue from both. The two distinct user groups benefit each other. The consumers get content, that's their utility, and then the content providers get subscription and advertising money. So now I want to go through a breakdown of price per gigabyte. Assume you have like a 10 meg service, 6 to 10 meg service, and you pay $50 a month. This is all publicly available pricing. If you're a heavy video user, you might use 150 gigabytes per month. Divide that into $50, so you're paying 33 cents a gigabyte. But the content provider is only paying half a penny or 3 cents per gigabyte. So end to end, the price per gigabyte, over 95% of it for this heavy user is paid by the consumer. For the average user who's downloading 20 gigabytes per month, they're paying 99% plus of the cost to deliver that gigabyte through the network. So being able to convert from megs per second and the price per megs per second to gigabytes per month, you can then sort of look at this pricing holistically, end to end. Okay, so my summary is that the trends in the internet are presenting challenges to ISP providers, content providers, every segment of the network. And then my question, which I'm not going to answer, I'm just posing the question, is do the pricing structures we have in place accommodate paying for the infrastructure? Are they appropriate? So that I'll just leave as a question. Okay, are there any questions?
Hi, Jeff Houston. This problem is obviously as old as the internet. The real challenge to anyone is more traffic should equal more money, because if you wish to buy more resource, whether it's bandwidth or anything else, you need more money to purchase it. And ultimately what you're really saying is, does the 95th percentile pricing model represent a sane business strategy? Interestingly, the US was one of the unique countries that ignored any form of volumetric charging and went straight to 95th percentile, proving this industry is a bunch of sheep. It was actually Mike Odell of UUNet that started this, and it only ever took off in this continent. Everyone else went straight to volumetric. I don't quite understand why, and what you're pointing out is that 95th percentile assumed a certain peak to mean ratio that volumetric didn't. Right?
Right.
And as the characteristics of the networks change in terms of the behavior of users, 95th percentile has its problem. The other blindingly obvious problem with 95th percentile is that it's a lie. It's a lie because users, or at least consumers, can't replicate the measurement being made by the provider. Billing disputes are actually unresolvable, because when you go back to your explanation of what is 95th percentile, you start to get into this issue that, oddly enough, both consumer and producer can deploy precisely the same equipment and use the same algorithms, but if their time base for this bandwidth is different, you and I can do the same thing and come up with different legitimate measurements of what are the peak bandwidth points, oddly enough.
Right.
Get over it.
Yeah, there's a lack of transparency.
Get over it. Charge by volume and just get over it.
Yeah, thank you. That's a good point. Charge by volume, but at the same time, the backbone providers need some indication of the peak. So maybe in order to design to the peak.
No, they don't. They just need money.
Well, then we need to change the billing approach.
But then you get into this whole issue of what's your business model. And as
Right,
we've
right.
seen in this industry with both the mobile providers, AT&T being notable, but Sprint as well, and indeed with a lot of the ISPs, the business models are structurally broken. And that what they find is they're actually incapable of actually charging for more usage should equal a higher bill. And then they get into flat rate, and then life gets crap for everybody.
Right.
And yes, the business models are broken, and 95th percentile is actually at the heart of a lot of this.
Right.
It's broken.
Right. And then on the consumer end, all of the companies end up playing chicken. Who can reduce their price and get the most customers? But then we offer flat rate billing, and people use as much as they can, and then it's difficult to design to that, to provide that, and still make profit.
I actually have a question too. Okay, Tom Vest. Just curious, have you done any similar studies about the actual cost of bit service delivery? I mean, I don't think anybody here would think that the cost of actually delivering service has been static. It's declined probably, I would say, along the same trajectory. Otherwise, everybody in this room would be bankrupt.
We absolutely have,
Yeah.
but that's proprietary data.
Right.
But the costs for equipment are not coming down at the same rate as the increase in usage of bandwidth, which is growing at about, in our case, 70% per year per existing customer. This is not even net customers.
So you, by cost of equipment, are you talking about sort of the, are you actually talking about the cost of bit service delivery using that equipment for the lifetime of the
Yes.
equipment itself?
Right, right.
So
the costs are not coming down as fast as the usage is increasing. And they'll reach a point
Right.
where, and we have that, where they'll cross. And
okay.
Yeah.
So it would be interesting to, again, so you highlighted the fact that apparently one side of the equation which would determine what's viable and what would be reasonable as a business model is basically structurally invisible. It's not possible to take into consideration by
Right.
anyone but you, and that's a permanent condition, I guess.
for now.
Yes.
Yeah. And then there's, I think another issue, the hidden elephant is, the elephant in the room is net neutrality. It has our hands tied in a lot of, you know. So.
Hi, Jason Ackley, Rackspace. Just disclaimer, we are actually a customer of Quest CenturyLink. Has there been any consideration, I mean, you said one of the tough parts is the peakiness and kind of absorbing all of that at once. We look at our graphs, we see when we're getting close, and we do shift traffic around, of providing like a feedback mechanism to the customer base and some type of incentive, like, hey, it would be nice if you could move a couple gigs off during these hours, almost like the utility grids do, not to say running out of bandwidth or power is a good thing, but just some type of feedback mechanism and incentive for the customer base.
That's a good idea. Just more coordination. And I think if there were more coordination, then CenturyLink could respond to the surges and would know where they're coming from and when. So, I mean, I think that's the solution, part of the solution. Yeah.
Jeff Houston again. You said it, I didn't, and I'm kind of curious. Network neutrality, our hands are tied. Why are your hands tied with network neutrality? Surely, if your job is delivering packets, your income comes from packets, not their color, shape, source, or destination. Why are your hands tied with network neutrality?
Two options, flat rate billing or consumption-based billing, and that's metered billing. That's been approved by the FCC, accepted by the FCC.
But why are your hands tied with network neutrality? What do you want to do that network neutrality prevents you from doing?
There could be more revenue opportunities in service delivery, optimization. I mean, sort of what Dave
You
Ward was
want
talking
to
about.
charge for different packets at different rates, do you? Is that what you're saying with your hands are tied with network neutrality?
You could
I'm
interpret
curious
it
as
that
to the
way.
comment.
Yeah, yeah.
So you have a relationship on one side directly with someone you call a customer, and no relationship at all with someone over the other side who's delivering packets of different colours. And you're saying that if you didn't have network neutrality, you could charge these remote people with whom you currently have no relationship with.
Well, there'd be more flexibility in how you could bill. We'll have to talk after. Yeah.
Thank you very much, Amie.